Okay, so I want to go through and just kind of review the stuff we talked about last time. Oh, you know what I need to do though? Hang on real quick. No, I gotta. Okay, so what we talked about, I remember Monday, I think it was, something like that. So we talked about dividing polynomials. So if we have two polynomials, remember what we did? We said if we have polynomial f of x divided by another polynomial g of x, we said that the answer is always going to look like this. We're going to get some answer, q of x, they call it the quotient polynomial, but we don't need those fancy names. It's just going to be a polynomial part of our answer plus some remainder, right? Some remainder over the original denominator, right? Now that remainder is just going to be, it might just be a number, it might be a small polynomial, right? But it's going to be a remainder. And so we'll get back to that. But then we went through the process of actually doing some division. That's what I want to do today. I want to just take a look at a couple sample problems. We'll look at a long division problem, and we'll look at one that we can use synthetic division on. And we'll go through this, because I think this part takes a little practice. There's a lot of steps to it. All right, so let's try this one. And you might even want to just work through this on your own. If you want scratch paper and you want to do that, here's some scratch paper. Feel free to grab some. So let's set this up. We've got this big polynomial up here, this third degree polynomial divided by this quadratic polynomial. Okay, let me have all phones away. Put those away in your pockets. Oh, okay. Oh, yeah. Well, it's not, but I'll find it. Oh, yeah, it is. It is. Thank you. Yep. Okay, so now, which one of those is the numerator? First one. Which one's the denominator then, obviously? Second one. Okay, so when we write this out using, can we use synthetic division on this one?
Yes.
No. Yeah. We can't. No. But why can't we?
Because it's x squared.
Okay, good, because the denominator has an x squared in it, right? If the denominator has any power of x bigger than 1, we cannot use synthetic division. We can only use synthetic division if we have a little linear polynomial there that's just got only powers of x to the 1, okay? Or even if it's just a constant, but we won't be doing that. We'll be dividing by a little linear polynomial. So we got to use long division here. So let's make our bracket. Now, which part goes inside? Okay, the 10x cubed plus, now I gotta be real careful here. Remember, I have to have a column for each power of x. Are any of them skipped this time?
No.
No, so nothing to worry about this time. 27x squared plus 14x plus 5. And then out front, we'll put the denominator. X squared plus 2x. Okay, question comes up sometimes. Do you have to put in 0 coefficients and leave a column for every power of x outside of the bracket in the denominator? And the answer is no, you don't need to. It's fine, you don't need to. Because when you do your distribution and you multiply, when you get answers up here and you distribute over that polynomial, you're just going to put them in the appropriate column inside, right? So you don't need to stretch that one out front out and put zeros in it. Only inside you need the zeros. Okay, so first step. What's the first step here? So first, how did we get the ball rolling on this stuff?
Divide the x squared x.
Right, okay. You know, this is going to get divided into this, but that looks complicated. Remember, we were able to focus only on 2 terms. Yes, ma'am?
Couldn't you like simplify it and divide everything by, I was going to say by an x, but divide them.
Right.
So
Yeah.
is it 10x cubed divided
By x squared. Good, good. We're going to see how many times does the leading term outside divide into the leading term inside, right? So we're just asking the question, what is 10x cubed divided by x squared? And the answer is 10x. Okay, so that's telling us that the first part of the answer is just 10x. Okay, now what do we do? What do we do whenever we get an answer on top in long division?
Times it.
Oh, good. Okay, we go back and we multiply. multiply through. Good, right? So 10x times x squared is
10x cubed,
10x cubed. 10x times 2x,
20x
okay, plus 20x squared, okay.
squared.
And,
You subtract them.
okay, we subtract it. So we're going to subtract that whole thing, right? Thank you. Okay? And if we subtract 10x cubed minus 10x cubed, of course those cancel. What's 27x squared minus 20x squared?
7x squared.
Okay, what do I do with the other terms then? Drop them down. So plus 14x plus 5 and start again. Start again. So now I'm going to divide, what, 7x squared divided by x squared equals plus 7, right? I'll distribute the 7 all the way through. What's that going to give me?
7x squared.
Okay, and I'm going to subtract that whole thing.
Zero.
Cancels, cancels. 5 minus 0 is 5. And that's my remainder, isn't it?
So that's what we're looking for on the.
Well, now, in this case, we're actually looking for the whole thing, because there's two parts to the answer. We're gonna have the polynomial part up here, plus the remainder part, right? Okay, so if we separate those two, we got this guy, so our answer is gonna look like equals 10x plus 7 plus
No,
5
7.
divided by what?
X squared.
There you go. Good. Divided by x squared plus 2x.
Yeah.
And that is my answer. Okay.
That's not what
No, it's not that bad, right? It's very repetitive. Okay. Once you get the hang of it, you just do it over and over again until you get down to a point where you can't continue the process any longer. Right? X squared won't divide into 5, so that must be the remainder. Okay, what about this one? It's a little easier. I could divide this out using long division, but
Couldn't
this
you do that
time,
one thing you said because it's not x squared?
good. This time I could use synthetic division, right? Because the denominator is linear. X is to the first power only. No x squareds, no x cubed, etc. So we can make this synthetic. Okay, now what numbers go in here?
X
And
cubed.
X,
Okay, so I got to put the coefficients, right?
yeah,
Yes.
1's the first coefficient of x
Zero.
cubed. 0, good. Got to have a 0 because I'm missing the x squared term. So there's a 0 coefficient for x squared. -7 and 6. Okay. Okay. And we can always do a quick check here. We can to make sure we got them all. Say it again. Oh, -6. Whoops. We can always do a quick check. If this is a cubic polynomial that's in the numerator, we always know we're going to have the whatever the degree is plus 1 terms for the constant. So I should have, if it's a cubic polynomial, I've got 3 plus 1 is 4 terms, and I do, so I know I got it.
and then the X goes to
Okay, yeah, and what part of that goes out front? Remember, the denominator, so I've got x minus 2, but I'm gonna actually, it's the 0 of that. I'm gonna set that equal to 0 and solve. So it's 2. So it's 2. The denominator is equal to 0 when x is 2, and so that's the number that goes out front, not the -2. And that's probably the most common mistake people make when they're doing synthetic division. They
So
tend
you
to want to
do
make
this?
that.
when the denominator is not squared.
Right. Right. If the denominator had an x squared in it, we'd have to use the synthetic division like we did in the first example. I mean the long division, sorry. Okay, and from here on out, this is really quick. Right, what do we get now? Okay, we drop down the 1.
2 times 1. 2.
Right. And we're adding with synthetic division, opposite of long division. 2 times 2 is 4 plus -7.
Negative 3.
and then I get -6, and I add those,
Oh, -12.
-12. Okay?
Queen.
Okay, and so how do we interpret that then? How do we interpret that? So, well, now, this is the answer, just like we had before. We know the answer's gotta be a polynomial plus a remainder. So this part right here, this is the polynomial part, right? Those are the coefficients, right?
We have 1x squared.
Oh, good.
X squared plus 2x minus 3.
Perfect. Yep, perfect. So that's the polynomial part. And it's easiest to work backwards on that.
Just, isn't it x cubed?
Nope, it's x squared, and here's how you know, because it always goes in order. It's gonna start with the constant and just work its way up through the various powers of x. And it'll never skip down here, as long as we put a 0 in up here. So this was our original x cubed, x squared, x, and constant columns. As long as we followed the rules, the coefficients down here are also gonna go in order. There might be a 0 in there sometimes. Okay, but I see what you're saying. This seems to line up with the x cubed column, but that's different. That's the x cubed column for inside the bracket. Outside of the bracket, the powers always get shifted by 1, because now I've got this remainder, and that becomes the constant. So the easiest way to deal with that is just to work backwards, just to write it down and say, okay, I know constant, coefficient of x squared, and just count backwards. Okay? So this tells me we get x squared plus 2x minus 3.
And then
Plus -12.
Exactly. Plus -12 over my original denominator, x minus 2. Okay? Make sense? Yes, sir. We can't. We can't. One thing we could do is we could just put minus 12 over x minus 2. Putting plus and negative is a little bit pokey, right? We could write that instead. See what I'm saying? We could write that as, we could just do this. Oops. We could just do that. No, because it's only that -12 that was in the top. Remember that this is the same thing. I can say negative a over b is the same thing as negative a over b. When I have a fraction, I can put the negative sign in the top if I want to, or I can put it out front. They mean the same thing. Yes, wait.
Am I correct, you can also write it as x squared plus 2x negative 15 over x minus 2?
Can't do that. Can't do that, because the 12 is the remainder, the 3 is not. The 3 is part of the nice polynomial answer. Okay, so you can't combine those two. This one goes over the denominator, this one does not.
So how do you know it's x squared then 2x?
Because there's only 3 terms. And so if I count backwards, I know I would start with the constant, coefficient of x squared, coefficient of x cubed, coefficient of x to the 4th. That's how I can tell where I stop. Okay?
Easy.
Okay, now you might notice something here. This looks an awful lot like, in fact, this is identical to what you did earlier in the chapter when we called it synthetic substitution. You remember what that did, though? Earlier in the chapter, I think it was in 6.2 when we did this, we said that if I take this polynomial, right, and if I put a 2 out front, wasn't that our way of evaluating the polynomial at 2, plugging 2 in, right? And so it just so happens that because we get the same answers for the remainder and the value of the function, they mean the same thing. Okay? The remainder theorem says if a polynomial f of x is divided by x minus k, right? So k is the 0 of the function. Then the remainder is just the function evaluated at that number. This coincides exactly with what we did earlier. So if I want to know what my remainder is, I could just plug 2 in and look in the box. The value of the function. If I plug 2 in for x everywhere, that's going to be the remainder when I divide those 2 polynomials. Okay? That's not a super big deal, but we're going to take advantage of it for one other reason that we'll get to. Okay? Look at one more of these real quick. Okay, so let's just try it. We can do this synthetically, right? Okay. So we make our bracket. What are my coefficients inside?
10, 5, 0, 4.
Hang on, 10, 5,
Oh, just kidding. 4.
4,
Negative 9.
Negative 9.
0.
0. Because I'm missing the x term, right?
Oh,
Gosh.
negative 9.
And then negative 1 out.
Okay, and out front we have the 0 of the denominator. So if I set this equal to 0 and solve, I get
1.
negative 1, right? Right? Okay, so now let's do the math. If I bring this down, I get 10 times negative 1
Negative
times negative 1.
Negative 5.
5.
5. 9.
Negative 9.
9.
0.
Okay. So what's that mean?
There's no remainder.
There's no remainder.
There's no
There's no remainder, right?
Well, no.
Now, so then our answer just looks like there's my constant, right? Coefficient of x squared, coefficient of x cubed. So this goes up to an x cubed in our answer, right? So we get 10x cubed minus 5x squared plus 9x minus 9 with no remainder, right?
Good.
Now, what does that mean when we have no remainder? Think back to your days of doing long division in grade school. If we had no remainder, for example, let's look at two real quick examples here to compare these two. The same thinking is going to apply to polynomials. If I divided 43 by 4, that's like saying 4 goes into 43 how many times? Well, it goes into 4 once. 1 times 4 is 4, right? Bring down the 3. Does it go into 3? 0, right? And if I subtract, I get 3 is my remainder,
Yep.
right? So then my answer was this is equal to 10
10 plus 3.
and 3/4. So is 4 a factor of 43?
No.
No, it's not, because it didn't divide in evenly. I had a remainder, right? Okay, but if I divide 4 into 44, 4 goes into 4 once. 1 times 4 is 4. Bring that down, they cancel. 4 goes into 4 once with 0 remainder, right? So, in other words, 44 over 4 equals exactly 11. Is 4 a factor of 44? Yes, it is. Yes, it is, right? Same thing is true for polynomials. Let me ask you a question. Is x plus 1 a factor of 10x to the 4th plus 5x cubed plus 4x squared minus 9?
Yes.
It is. There was no remainder, right? So it divided evenly into that. How about that? Okay. Was, no. X minus 2 was not a factor of this cubic polynomial because I did get a remainder, right? Okay, so that's very useful to us. So in other words, I can take my answer here and I could say the original polynomial. Now this is real important. Make sure you see this part. So the original polynomial, 10x to the 4th, whoops, 10x to the 4th plus 5x cubed plus 4x squared minus 9 equals this guy. Times what? X plus 1. Exactly. See that? Right? If this quartic polynomial, 10x to the 4th, etc., divided by x plus 1 equals this cubic polynomial, isn't that the same thing as saying this cubic polynomial times x plus 1 equals the big polynomial?
Yep.
Right? Okay, so this is a great trick for us. If we know a 0 of a polynomial, we can divide that through synthetically, and whatever the remainder is, or whatever the answer is, the polynomial part, because I know that I'm going to get a 0 here, then I've effectively factored that polynomial, right? I factored this one out of this guy, and I got this left over. That's going to make your lives a lot easier, because you don't have to do so much factoring. Okay, so for example, let's say we got a problem like this here. I'm going to skip this for just a second. Let's say we got a problem like this. We've got this cubic polynomial that we want to factor, but if we're given that -5 is a zero of the polynomial, right? Then what's the factor that goes with that? If -5 is the zero, then x minus that is the factor, right? Isn't that what we always did? If we look at these examples we just did, when I told you that x plus 1 was the factor, you immediately told me that -1 is the zero. And the reason you did that is because you said, okay, if I set this equal to 0 and solve, that's the answer I get. In other words, x minus what? Equals 0, right? -1. Okay, does that make sense? Same thing over here, right? Same pattern held. Here, if x minus 2 was the factor, then 2 was the 0, right? That's the number I'm subtracting from x always. So that's the pattern we have. Right, so we can always make that correlation. In fact, on this list, this is a useful list. This is in your book, I think, actually it's in 4.8. This is a very useful list because all these things mean the same thing. They're interchangeable. If I know that k is some number that's a zero of a polynomial, then I know that x minus k is a factor of that polynomial. And another meaning of 0 is that k is a solution of the equation when we set the polynomial equal to 0. Okay. Really, we're just worried about the top two for now. That's fine. These two go together. Okay. So then, this guy right here, look, we can make short work of this. This ends up being really easy. If we want to factor this polynomial and we know that's a 0, right? Well, can I just do this? Can I just set up a synthetic bracket? What's the number that goes out front? -5, right? Because that's the 0. Does that make sense? So -5 goes out front. Before I'd even do any more, what number is going in there? 0. Right? It's a 0 because we're told it's a 0. Right? Right? When I put -5 into this function, I get back 0, and that's the meaning of that box. Right? That's what the remainder is. So this is pretty simple. Then all I have to do is put the coefficients in here, which are what? 1, -1, -21, 45, right? Bring down the 1, -5 times 1 is -5, add them up, -6, +30, right? What, 9, -45, and it worked. I got 0. Okay, but more importantly, look what we just did. We just took this polynomial right here, and we factored it. We took this guy, x cubed minus x squared minus 21x plus 45, and that's equal to this, right? What is that polynomial?
X squared minus 6x
Plus, yeah, right? Everybody agree? There's the constant, coefficient of x squared. So that becomes x squared minus 6x plus 9. And then the other one comes from here. If -5 is the 0, then x minus -5 is the factor, right? X plus 5 is the factor that goes with that. So look, I factored it. And now it's easy. Now I've got a linear one, and I'm down to the point where this is quadratic. And so that's either going to factor easily or it's not going to factor. Right? If that factors, are there magic numbers that multiply to +9 and add to -6? Yeah, -3 and -3, and x plus 5, right? So knowing that no one is 0 of this made it really easy to factor, because we're able to just synthetically factor that out. It's even easier if you're not trying to factor it, which is typically what we do. So this is even an easier problem. If they give us a 0 and we want to find the other zeros, we don't even have to do any factoring. We can just use the quadratic formula if we want to. right? So in this case, you see if you got this. You tell me the steps to go through. If I want to factor this, I know negative 3 is a 0. So how do I synthetically factor? Okay, I gotta put the bracket up. Okay, negative 3 goes out front. Good. And what goes in here?
0.
0. Right? And so I get 1, negative 3, negative 2, 6, 8, negative 24, right? And so I got 1 0 is negative 3. If I want to find the other zeros, look how easy this is. This is quadratic, isn't it? Isn't that just A, B, and C? Right? Agreed? Because isn't this just going to become x squared minus 2x plus 8? So you could always just plug those numbers into the quadratic formula. In this case, it's probably easier just to factor it, but you could always use the quadratic formula to get the other factors right from there. A, B, and C follow the quadratic formula. This one factors, well, this one factors a little bit easier, doesn't it? It's going to factor into what? What two numbers multiply to 8 and add to negative 2? Oh, actually they're rotating, aren't they? Never mind. Aren't any such numbers. But those multiply to negative 8. Right? And so it turns out there actually aren't even numbers, but we can use the quadratic formula and find it. Right? I can just, here's my A, there's my B, there's my C. So I get negative B is 2 plus or minus the square root of B squared would be 4 minus 4 times 1 times 8 all over 2A, right? And that's going to give us 2 plus or minus the square root of 4 minus 32 is negative 28. So I get 2 plus or minus the square root of 28I, right, all over 2. I can go either place. Doesn't matter. Either place. It has to be outside of it. Okay, makes sense? So even though those are imaginary, but it was just served right up to us because all we had to do is plug those numbers into the quadratic formula. You got the idea?
Yeah.
Okay, good. Wow, that was good. You did a great job.